All right, so on that last problem we did, in order to find the partial fraction decomposition of this guy, we guessed that it would look like this. And then that led to having to find A, B, C, and D. That would make this equation true. Now, what we did is we just started plugging in numbers for x. We did the Heaviside method. And it turned out by plugging in numbers for x, it all worked out great. Well, I kind of cherry-picked this example. Sometimes when you use the Heaviside method, it doesn't work out great. So what happens a lot of times is you start to use the Heaviside method, and you'll only be able to get a couple numbers. And once you've got a couple numbers, it's like you're stuck. You could plug in some other numbers to get some equations, or to find the remaining numbers, you could go with option number 1 that we taught. So if you recall, option 1 was as follows. So we have 4x squared equals ax plus b times this stuff, c times that stuff, plus d times that stuff. Now, by the way, I wouldn't bother writing all this down. I would just watch and look at this video later to get the gist of what I'm saying now, and just keep in mind how we would do option 1. So on other problems, if you got to use option 1, well, here's how you would do it. So anyway, all right. So we want to find A, B, C, and D. Okay, so what we could do is we could start multiplying stuff out. We could do x minus 2 times x plus 2 is x squared minus 4. We could do x squared plus 4 times x plus 2 gives you that. So you got to distribute. X squared times x squared times 2. 4 times x, 4 times 2. Over here, you could distribute. X squared times x squared times negative 2. 4 times x, 4 times negative 2. So once you distribute, you get this next line. You get all this stuff. All right, and then what you could do is you could multiply out. You do ax times x squared, ax times negative 4, b times x squared, b times negative 4, c times all this stuff. You do d times all this stuff. So you can multiply everything out. So it's a pain in the butt for us to do, but a computer doesn't mind. So if you have a fancy calculator, like maybe a TI-89 or something like that, or TI Inspire CAS, which you can't unfortunately use on the test, but calculators don't mind doing this. So you can multiply everything out. And then what you could do is you could factor. So you could collect everything with an x cubed in it and factor out an x cubed. You could collect everything with an x squared in it and factor out an x squared. Everything with an x in it, factor out the x. And then you have your constant left over. Okay, why was this helpful? Well, we have a polynomial on the left side of this equation, and it equals this polynomial on the right side of the equation. Rewrite this polynomial on the left side as 0 times x cubed plus 4x squared plus 0x plus 0. So this polynomial, it's the same as this one. Why is that helpful? Well, we have degree 3 polynomial on the left side of the equation. We have degree 3 polynomial on the right side of the equation. If this polynomial equals this polynomial, then this coefficient, a plus c plus d, it must equal this coefficient. So this guy right here, it's got to equal that guy. Over here, this coefficient, the coefficient in front of x squared, has to equal this coefficient, the coefficient in front of x squared. So that must equal that. All right, this coefficient here in front of the x, it must equal this coefficient here in front of the x. This constant term, it must equal this constant term. This allows you to set up a system of equations. This stuff has to equal 0. This stuff has to equal 4. This stuff has to equal 0. This stuff has to equal 0. So you have this system of equations. So you have 4 equations in 4 variables. Yuck. Now you can solve this by hand. It's not a lot of fun. So I recommend putting this into your calculator. So you want to make a matrix. So the coefficients here on your variables. Coefficient in front of A is 1. Coefficient in front of B is 0. B is missing, so think of it as 0B. Coefficient in front of C is 1. Coefficient in front of D is 1. Then you got a 0. So you can enter that into your calculator. So hit second, matrix. Go over to edit. And you're going to make a matrix. So I already did this matrix. I put it in as matrix C. And we want to make a 4 by 5 matrix. We got 4 rows, 1, 2, 3, 4, and 5 columns. 1, 2, 3, 4, 5. Enter in your matrix. Quit. All right, now hit second matrix. And go down. Go over to math and go down to reduced row echelon form, RF. So I want to do second matrix. C, reduce row echelon form on C, and your calculator spits out this. Aha! So what your calculator just told you is this system of equations. If you do elimination, so if you multiply these equations by numbers, add them together, rearrange them, turns out you can turn this system of equations into this one. So look at what this top equation is saying. 1a plus 0b plus 0c plus 0d equals 0. Wait a minute, that means a equals 0. Well, then this equation is telling you b equals 2. The third equation is telling you c equals 0.5. And the last equation is telling you d equals negative 0.5. So this is worst case scenario. I mean, don't be freaking out. My point is this. Sometimes you got to solve ugly systems of equations in order to be able to do the partial fraction decomposition. Your calculator can do it for you. And if you're big into computer programming or numerical methods or something like that, you'll learn all about this stuff more. But here's like a worst case scenario for you guys. Hardest problem you could ever have to do involving partial fraction decomposition.